Okay, here's a quick recap of Lesson 87, two-way tables. Now we started off with the rule to identify independence, and that's the probability of A times the probability of B is equal to the probability of A and B. A two-way table is a visual way of categorizing things or people based on two criteria. For example, I could categorize you both based on your gender and also your favorite subject. There are some distinguishing characteristics of a two-way table, specifically that the totals are on the bottom and the right. So the total for this table here, there are 19 boys who play basketball, 17 girls, and 36 total. So all the column totals are at the bottom. And we also have row totals. So if you want to add up sideways, 19 boys plus 0 boys plus 8 boys is 27. This row total, 17 plus 11 plus 0 is 28. And it actually even works in these. 36 plus 11 plus 8 is 55. And it works here too. 27 plus 28 is 55. And the number in the very bottom right is our sample space. That's the total number of people or items that we're dealing with. The total number is in the bottom right. So let me go through one example on the back. I'm going to do the example that we did for homework. Now, a factory makes 3 sizes of bookcase. Each bookcase can be made from pine, oak, or yew. The two-way table below shows some information about the number made in 1 week. Now, the table's not fully filled in, so what we have to do is a little bit of math. 23 plus 34 plus 13. So that'll give me this number down here. 23 plus 34 is 57, plus 13 is 70. So this number is 70 in the bottom right. Now 20 plus 14 is 34, but these should add up to 70, so 70 minus that is 36. Now this row should add up to 36, so 36 minus 16 minus 8, that's going to be 12. 7 plus 12 plus whatever should equal 23. 7 and 12 is 19. Plus something is 23, so let's do some subtraction. 23 minus 19 is 4. 7 plus 3 plus this should equal 20. 7 plus 3 is 10. Plus 10 is 20. 4 plus something plus 2 is 14. 4 and 2 is 6. 4 and 2 is 6. So let's see, 14 minus 6 is 8. So 8 goes there. Now we have the full table filled in. All of your row totals should add up. Sorry, these are column totals. All your column totals should add up. And your row totals should also add up. So if you check, you always can. Now, simple probability first. What is the probability of getting an oak bookcase if I picked one at random? So how many oaks are there? There are, let's see, 10, 16, 8. There are 34 oaks. 34 total oaks. So 34 oaks out of 70 total. And you could simplify that by dividing them both, or you can turn it into a decimal. If you simplify it, it turns into 17 over 35. So that's simple probability. You're always looking at the totals. Now 26, what is the probability of pine and large? So this is and, okay? So how many are pine and large? These are also considered intersections. So it's the intersection of the pine row and the large column. So it looks like the intersection is over here on 4. So there are 4 large pine bookcases. Those are the ones that fulfill both these criteria. Are they pine? Yes. Are they large? Also yes. So there are 4 of those. Out of how many total? 50, no, not 52. Think of a different question. Out of 70. And you can simplify that to 2 over 35. Now let's do one union question. What is the probability of pine U oak. The U is a union. It means an or. So we're adding them. So the probability of pine or oak, that means the probability of pine plus the probability of oak. Well, let's see. There are, didn't mean to delete that. There are 23 pines and there are 34 oaks. So if I add those together, 23 over 70 plus 34 over 70, I get 57 over 70, and I believe that's as simple as that's going to get. Now I'll do one independence question. Are large size and U construction independent? Well, here's the test for independence. I'm doing 32. The test for independence says this: the probability of A and B must be equal to the probability of A times the probability of B. Well, we're talking about two conditions, A and B, so I'll take large size and I'll make that A, and U, construction, will be B. So the probability of A, this right here, that's the probability of getting a large size bookcase. How many large size bookcases are there? There are 14 large out of 70 total. So this is the probability of large times the probability of U. And this on the left is the probability of large and U. So the probability of large, I think we just agree, is 14 out of 70. The probability of U is 13 out of 70. So 14 out of 70 times 13 out of 70. And that should be equal to the probability of finding a bookcase at random and it being large and U. And made of U construction. So let's see. How many large U bookcases are there? 2 out of how many? 70. So this is 2 out of 70. Now I'll take this on the right hand side and I'm going to take it to my calculator. Let's see, 13 out of 70 times 14 out of 70. And the question is that equal to 2 out of 70? Those are not the same number. Those are absolutely not equal. So since they are not equal, they are not independent. Therefore, they are dependent. Okay, and that is the final skill to be pulled from lesson 87. Okay, see you in class.